Hey everyone, and welcome to the Extension 2 lecture series. Just a few things I want to say before we really get started. Firstly, a brief disclaimer. I don't know what Jamin is doing, so for all I know, these might be done completely different to what he did for 3 unit. Just a reminder that these are of course video lecture recordings, so at any time you can slow down, speed up, or pause the video. Every now and then I'll also make a recommendation as to when you might want to pause the video and just slow down, digest everything, or to read a question or so on. I'm not going to do anything too fancy today. Mostly my lecture slides are just going to be for reference, and my webcam is, well, it's there, but it's going to be really hard staring into a black dot the whole time, so I might not always look into it. And that's for admin. As for the lecture itself, well, I thought most of the time spent during my trial survival lectures, they were mostly focused on content itself, so this time I'm going to reduce the amount of content I do. I'm mostly going to focus on what I feel will be more useful to you as a student going into the HSC, and from then on we'll just roll with it, yeah? Alright, before we get too deep into it and get my cursor out of the way, just in case anyone was doubting me during the trials when I said this, I was not kidding when I said that I had a friend that got around 40 or 41 for the trials, and they ended up getting a band E3 anyway. It's a 96 ATAR. It is possible. The core scales heaps, but the idea is to put a lot of effort into your final exam, because that's what's going to count the most. It practically counts for like 50% of your final mark, and that's really huge. So honestly, persistence is key. Keep going at it, and I guarantee you this course will be successful. And remember, at the end of it, you probably don't need to do math as stupid as this again anyway. Alright, let's get a move on. So honestly, you'll probably know this from my lectures, from the trials, but remember, it's not necessarily about how good you are at math, it's more about how well you can get your marks. Your primary goal at hand is mark maximization. And what happens is, you might be really smart, you might know how to do this and how to do that, but then what will happen is on the day, you'll bump into a question that you might think is either too easy, or you just get lost in really messy algebra, and then you'll be like, oh crap, I just made a silly mistake, and boom, unless you spot it, that's a lot of hopes and dreams shattered in potentially 1 mark. Bit dark, but I'm sorry about that. Else, you might end up not answering the question, you might just go on derail off to your own tangent, no pun intended. And also, it's really like English in a way in that you should always give a question a go. Anyway, you might not know if you're on the right path or not, but you never know if what you write down will be pretty much the key to success. So pretty much, mark maximization, remember it. Reminder, reading time is bloody sure you only have 5 minutes, you can't expect to do much during it. Reading time is something that you only use to basically at most generate your ideas. Think about which questions might lure you into traps like, silly mistake, for example. Don't try doing problems until you're absolutely sure that you basically read through the whole paper and you actually know what's going to happen in the exam, which you unfortunately most likely not. That's just everyone. And you might want to think about which topics that you find you're good at, well, the questions that are related to the topics that you're good at, and which ones that you're not as good at, and then figure out which ones you want to do first. And pretty much, just think about ideas. Some questions in the exam, you'll see like, for example, here's z equals 3 plus 4i, w equals minus 5 plus 12i, they want you to find z over w bar. Questions like this, just get it done with. They're nice and easy marks. Like I know there's a rule of say, you should probably spend about 1.8 minutes per mark or other way around, but honestly, you should know better than that. Like, that is a good guideline, but you shouldn't really take it for Bible. You should just basically get easy questions out of the way, and so move on so you can spend more time on the harder questions. Okay, you're not going to be able to get every question on the paper unless you're basically one of those people who want to stay ranked, right? So, remember, if you're spending too much time on a question, just move on. Literally, none of us are going to be perfect, except for maybe like one person in the state. This is 4 unit after all. Really think about which question you should do first, and I left an exercise I'm just going to read for you guys. There are 8 topics in this course, and I want you guys to rank them from the hardest to easiest for you. And pretty much, like I said earlier, but basically that will give you an indication as to which topics you want to attack first. There is no rule of thumb as to how you want to check your answers. I gave my advice for not my advice, but what I do for when I check my answers, and it's all right here for you to read if you want to pause the video. You should think about what will basically be your most optimal strategy to check your answers. There isn't really like a universally brilliant one. And silly mistakes are pretty much one of the big things that distinguishes a state ranker from an ordinary band 84 person. So if you can get into the habit of checking your answers so well that you eliminate pretty much every single silly mistake you make, that's going to be absolutely brilliant. So do it, right? And of course, there has been drama in the past about, oh, this question appeared back in this paper and now it's been put here again for some reason, and people thinking, why did this even happen? But that's not going to be very common. Most of the time, the questions you'll see are going to be something that you probably have not seen before. So you might mind blank, you might stress, and the problem is basically how you're going to deal with it, because that's all normal, but dealing with it is what's actually important. So, like, drink some water. I should probably do that more every now and then. You might want to take some of these more bits of advice I give you, like highlighting bits of information or underlining if you're that type of person. Perhaps the most important thing is to really break the question down, because you might not be able to just get the ideas of how to do a question literally on the fly. You might need to take your time to think a while for it. Break the question down and see what you think might be appropriate to use. There's no guarantee that you're going to be on the right track. That's unfortunately the hard truth. But give it a shot, test your ideas, and just count on the fact that it might work or it might not. If it really doesn't work, then that is going to be really unfortunate, I guess. But if it does work, then hey, you saw yourself like 3 of the hardest marks you can get in math in Australia. So perhaps big emphasis on using everything you know, and I'll go on a bit about that later though. And when I literally say expect the unexpected, I mean literally that. I'm pretty sure in 2014, i.e. in Jake's year, none of them would have expected this kind of basically integration B level integral to pop up as the final question of an exam. You might not know what to do, but you think about how you could possibly approach it, and you never know, you might get the correct answer. And that's basically, you know, the stuff from back in the trials, and hopefully you're going to be happy now. I'm going to give you some more stuff, well, at least hopefully you are. So firstly, very quick remark on skipping steps. I touched on this very quickly during my trials, I guess, but all I really want to say is, when it comes to skipping steps, take one of two approaches. Approach 1 is to just not skip steps at all, because you want to be on the safe side. Just learn to write really, really fast like you do in English, and get as many things done. I mean, basically get as many things as possible onto the paper. The other thing that you might want to do is basically skip steps when you feel what you're writing is insanely obvious, or as mathematicians call it, trivial. If that's the case, then, I mean, the examiners know that you're an Extension 2 student. They're not going to care if you want to just sit back, see if you know how to do the thing properly. If you know, if it's blatantly obvious to them, yeah, just do it. Quick remark about, well, not really quick at all, but remark about the multiple choice. Multiple choice is nice because you can just sub in basically your values into what you're given. You can use guesswork, and you can use your calculator to help you out. So I'm just going to show you a demo of a CSSA question that stumped me at the time I did it, during study or something, and pretty much, I'm going to start by just looking at what I've got. So I have complex numbers Z and W, and I have the property that Z is not the negative W, and something really, really random. And I do have to do a bit of work with it, like it's not something that's just immediately doable straight away. I'll use my identity of complex numbers. Hopefully you're decently good at that by now. And I'll eventually realize, oh, okay, so they have the same modulus. So I'm thinking, well, okay, same modulus, and they're not the same number or the negative of each other, so I'm just going to pluck any random numbers out of thin air that work. You can check for yourself that 1 and I are going to satisfy these properties. That's pretty obvious. And then what do? I just sub them in. So, I mean, I could be fancy and just use my fancy-dancy calculator here, or I can do this by hand, but the idea is, if I sub in my numbers in, I'll get the argument of blah, 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 and according to my calculator, the answer is pi on 2. And when I think to myself, well, okay, pi on 2 doesn't appear anywhere else here, so surely it has to be the correct answer, right? So I'm going to basically just count on it being right. I'm going to say C is the correct answer. It turns out it is, and there is a normal way of doing it, but yeah, let's not touch on that. And you might want to pause the video here. I'm going to give you guys some easier examples to do, and you can pretty much do them the same way. You can just use guess and check, and good luck. Shouldn't be too hard. Alright, and next is this sort of stuff I like to call forbidden techniques, because yes, they are forbidden. You're not technically supposed to use them during the HSC, so long as you're really careful with how you use them, though, you can probably get away with it by either doing it on scrap paper or on the question booklet, somewhere where they can't see what you're doing, and then they can't penalize you because you didn't do anything wrong. And the first one I want to show you is something you might have seen before. It's basically L'Hopital's rule for evaluating limits, and the idea is, for your purposes, if you're given a limit that takes the form 0 on any of these forms, 0 on 0, or infinity on infinity, or that really, really weird one, what you can do is that under really mild conditions that you don't really have to worry too much about, under those conditions, what you can do is that you can just differentiate the top and the bottom, and it will still give you the same final answer. Which is really, really nice, because it's a good check. It's not what they want you to do to actually evaluate the limit, but it can be really nice to check it. Very quick to you, an example, you might want to pause the video, I'm going to talk about it really quickly. Very easy example, if you sub it in, you get 0 on 0. So, you satisfy your requirements, I'm going to differentiate it, and then evaluate my limit from there. Oh, well, you should probably say 3, but either way, basically it will give you the correct answer if you do it the normal way as well. Excuse me. So next up we also have a random limit I plucked from an HSC paper. This was not really the most obvious limit. If you've seen it before, then you probably know the intended approach, which I might make a brief remark on, but the idea is, in this situation, obviously if we try to sub infinity in, we're going to get infinity times sine of 0, which is infinity times 0. So again, we can differentiate the top and bottom, but we do have to tweak it a little because we don't have a denominator yet. So basically what I'm going to do is I'm just going to chuck the n here on the bottom as 1 on n instead, and I'm going to differentiate that. And then once I get here, I'll differentiate it, and then I'll simplify some stuff out and I get this limit. Well, that's easy enough. Now I can just sub it in there to get pi on 2 times cos of 0. Hopefully you're used to that by now. And I'll guess that my answer is probably pi on 2. What's next? Yeah, so the correct approach is here. If you want to pause the video and look at how you do it properly, well, the intended approach was basically for you to just take your limit, look at it, and then see what you can do with it. And the idea is that if it involves like x or sine x, usually it's going to be the limit of sine x on x. And it's not obvious here. The idea is that to make it more obvious, what you do is that you can just perform one little substitution, and then it'll convert into the form that you require it to be. And that's, as you know, 1. Apologies that the lecture recording doesn't flow. There were some major typos in my slides I had to fix up. But anyway, we're back. And the next thing I want to show you is what's called Eulers formula, or Eulers formula if you've never seen his name before. And Eulers formula is basically a nice way of getting out of using that ugly cis notation that every mathematician hates. And the idea is that, believe it or not, your standard cis theta, your cos plus I sine thing, is actually just equal to e to the power of I theta. Don't ask me why about that for now. We'll just talk about how this might be useful for you guys. And the idea is I'll give you a random question, and I want you to show you that this really weird trig expression can be simplified something in terms of tan, which it seems fair enough, and you might be tempted to just jump straight into it and then basically do your normal division by multiplying the conjugate, blah, 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 blah. The idea is that this question could be made a lot less harder if you just know this trick to it. And the idea is that what I'll do is I'm going to write my whole thing out. I'm going to write it in a cis notation, but then once I get to the cis, I'm going to go back into the Eulers formula notation, so the exponential. And then the trick is that exponentials make it easier for you to visualize your index laws, and you'll see now all I can do here is just factor e to the I theta on 2 out, which might seem really weird, but the idea is, of course, it's going to cancel as you'd expect. And then once you cancel it out, you rewrite it back in your cis notation, convert it back into basically the cos plus I sine, and you'll find it simplifies to something really, really neat. And there you go, there is your final answer. And one remark I do want to make is that this is completely optional. You don't need to... Euler's formula isn't really as useful as L'Hopital's rule as far as extension to math goes, but it's a really nice handy trick and it can make a lot of things easier to visualize. Alright, so I'm running out of time for this video, so I will leave it here and I'll see you in the next one.